Water is an extremely important molecule in both biology and chemistry. So let's try this one together. It's a little bit more complicated than the others. So first we need to draw the Lewis structure for the molecule. So water is made up of H2O. So we know that an H looks like this, and the O has 6 valence electrons. So it has 4. I'm going to make sure that these two can connect since I drew the H over there. And then if you remember, wherever you put the double electrons, next to it also has to be double electrons. So it has to look like this, giving us this bent shape for water. All right, and then I put another H on the bottom so that these two can connect. All right, so let's connect them. Okay, so now the hydrogen has 2 electrons around it, which is what it wants. The 2 is the line here, because that line represents 2 electrons. And then around the oxygen, we need to have 8 electrons. Well, we have 4 from the dots. There's 1, 2, 3, 4. And then we have 2 lines, which is another 4. So there's 8 around the oxygen, which is what we're looking for. Okay, let's look up some numbers. Hydrogen we know is 2.1, and oxygen is 3.5. And again, we're getting this from that periodic table. Okay, now this is a little bit more complicated because there's 3 atoms here. So I'm going to change the color. But overall, we still see the same thing here. We have a 3.5 and a 2.1. So what's the difference between these two? It's going to be 1.4, which is still in that polar range, right? The polar range was from 0.4 up to 1.9. This bond is definitely going to be polar. And which of these two is the more electronegative element? Yeah, exactly. It's the oxygen. The oxygen's more electronegative because it has the higher number, right? The 3.5, which means around the oxygen, it's going to be slightly negative. Now, we just checked it for this, right? We saw this hydrogen and this oxygen. We only checked it for that one. But because this hydrogen and oxygen are the same, whatever we did for that one on the bottom, it's going to be true for the one on the left as well. Okay, we do need to add something else to this because we had the slightly negative part, but now what's going to be the slightly positive part? Yeah, exactly, the hydrogens. So if we make the lowercase delta with a positive sign next to both of the hydrogens, then we'll be pretty good. So this looks a little busy, so we can clean this up. Okay, so this is one water molecule here. Now let's say another water molecule wants to be close to this one, because we know that water sticks to itself. You get water droplets that way. What would I draw over here, close to this oxygen? Would I put another oxygen here, or would I put a hydrogen there? Yeah, exactly. We're going to put a hydrogen. So let me draw another water real quick. Now, why did that hydrogen want to be close to that oxygen? Exactly. This hydrogen is slightly positive because we just saw it here, so it's going to be the same for all water molecules. And this oxygen is going to be slightly negative. So why would these two want to be near each other? Because opposites attract. So this is going to form a little attraction between these two water molecules, which is very important.